everyone, very good morning to all of you. So students, I hope all of you are preparing really well, working hard for your KCET examination. And from today onwards, like as you know, from yesterday onwards, we have started this live session where we will be solving this rank booster questions, right? So what is this rank booster series? So we will be not taking the very easy peasy questions. We coming up with some very good questions, a good level questions that can actually help you to boost your rank. Okay, so I can say so many students are live here. Pankaj, hi, hello. Bhuvan, hi. Mithun, it's 12, ma'am. Okay, sorry dear, good afternoon then. I'm really sorry. Good afternoon to all of you. So Srinivas, hi. Srinivas, Venugopal, Monu, Suresh, Sujal, Aman, hi and hello to everyone. Okay, so students, before starting the session, okay, every day, please, I have something for all of you. All of you have to comment this. Okay, yes, I can do it. Okay, we have just this 14 days, I can say like 10-15 days we are left, right? These few days that is left with us, we are going to put 100% of our effort, right? We are not going to think anything about the result. What exactly we can do now is to put our 100%, and we all will do that. We will also do, you will also have to do that. So please comment down that you will all work hard from today onwards if you haven't started yet. Okay, so with this positive note, yes, very good students, that's the spirit. So yes, with this positive note, we will start the class. We'll go for the first question. So this is a mixture of all the chapters. Basically, I have taken 5 chapters in this particular lecture: solutions, kinetics, electrochemistry, coordination compounds and DNF block. All high weightage topics from where you can expect 4 to 5 questions easily. Okay, let's get started with the first question here. Please see the question and give me the answer quickly. Okay, so there are 30 questions. You have to give yourself a score, and at the end of the session I want all of you to put down your scores. Okay, so which one of the following statements is not correct? Increase in pressure will increase the solubility of the gas in liquid. At high pressure, the number of gas molecules per unit volume over the solution will increase. Dynamic equilibrium exists between the molecules in the vapor and in the solution. At high pressure, the solubility of gas gradually decreases until it reaches an equilibrium state. Which is the correct statement? Is not correct. Sorry, question is asking here, be very careful, not correct. So we know according to Henry's law, if I increase the pressure, the solubility of the gas will increase, so it is a correct statement. At higher pressure, the number of gas molecules per unit volume will also increase. Yes, if I increase the pressure, the gas molecules will come closer to each other, so number of molecules per unit volume will increase. Dynamic equilibrium exists between the vapor and in the solution. That is also correct. Yes. At high pressure, solubility of gas gradually decreases until it reaches the equilibrium state. So this is incorrect statement, so option number D here. So these are PYQs. I have also included PYQs, but these are not only PYQs. We have different variety of questions. Okay, do not worry. Next question. This is very important question. Tricky question, please all of you solve it. A gas X is dissolved in water at 2 bar pressure. Its mole fraction is 0.02 in solution. The mole fraction of the water when the pressure of the gas is doubled at the same temperature is. Very good question. Please all of you answer. Try this question for 1 minute, then I will be answering if you are not able to do it. Yes. Why is it incorrect? Okay, let's see. See here, at high pressure, the solubility of gas gradually decreases. No dear, you know Henry's law. What does Henry's law say? When we increase the pressure, solubility of the gas will increase, right? So here it is giving decrease. So that is why it is an incorrect statement. I hope this is clear. Next, here question number 2. All of you please try. Question number 2. A gas X is dissolved in water at 2 bar pressure. Its mole fraction is 0.02. Okay, so what is Henry's law telling us? P1 is equal to KH into X1, right? Now the mole fraction of the water when the pressure of the gas is doubled. Okay, we have doubled the pressure, so what will be the mole fraction of the water? Very, very tricky question. So you have a gas X, okay? It is the gas X which we are dissolving inside water. So now I can write that when I have doubled the pressure, so I can write P2 is equal to KH into X2. Okay, so P1 by P2 will be what? X1 by X2, right? P1 is, suppose initially how much was P1? 2 bar, right? So I can write 2 bar, and at the P2 is how much? You have doubled it, so it will be double of P1, so that is 4 bar, is equal to X1. X1 is what? We have mole fraction 0.02, okay, and here the mole fraction is, I have to find X2. So if I calculate, I will get X2 is 0.04, right? So the mole fraction of X, that is mole fraction of gas X when pressure is doubled, is how much? 0.04. Okay, that is the mole fraction of X. Question is asked to find out mole fraction of water. Here the trick is there, mole fraction of water. So mole fraction of water will be how much then? Mole fraction of water, that will be 1 minus 0.04, I will get 0.96. Okay, so we have the correct answer here as option number C. How many of you have got it? Many students have given the answer. Yes. Okay, so I hope all of you are clear. Let me repeat the solution once again. We know that when you increase the pressure, solubility of the gas will increase. That is according to Henry's law. So when 2 bar pressure was there, the mole fraction was 0.02. When you doubled it, means when you make it 4 bar, so that will also get double. So the solubility of gas X became 0.04. Okay, now 0.04 is the mole fraction of gas X. I want the mole fraction of water, so it will be 1 minus 0.04, that is 0.96. So option number C. Is it clear to everyone? Please put a thumbs up if it is clear to everyone, students. I will be knowing whether it is clear to all of you or not. Please quickly put a heart shape or thumbs up, something. You give me an indication that it is clear to all of you. Okay, okay, fine. Let's move to the, okay, before moving to this question, we have something for you. You all know we have very few days left for the exam, right, students? So at this point of time, the only thing that you have to prioritize is practicing questions, good level of questions, and that is why we have come up with Rank Booster series. We have top 30 question series, right? So similarly, you can also improve your performance by attempting mock tests, which is very, very important. So our channel provides you, Deeksha, Karnataka provides you this free this test series, that is Abhyas KCET 2025 test series. Okay, in that you will be getting 35 mock tests, which you will include subjects physics, chemistry, maths and bio. Okay, and these test series are like part test is also there, full length test is also there, and you will also be getting detailed video solutions, one shot revision videos and live doubt clarification classes. Okay, yesterday we had this live doubt clarification class, many students joined, right? So you can get your doubts cleared personally one-to-one. Okay, so that is there, and then this whole test series is available at just rupees 1498. Okay, so it is not 99, it is 1498. So you can avail and take proper practice and go for the exam. Already many students have purchased, and they are already ahead of you people. If you haven't taken, so please take it. The link is there in the description section. Okay, next, coming to this Comet K, many of you have requested for Comet K. So we have come up with the Comet K crash course as well. Okay, so here we will be having 12 mock tests, which will include 4 part tests and 8 full length tests. We will be completing the complete syllabus of 11th and 12th, 5 years of previous year questions, live doubt solving sessions, class notes, recorded revision videos, everything will be provided, and this is available just for rupees 1999. Okay, so clear? I hope this is clear. If you have any doubt regarding to any of this, you can call on at this number and clarify your doubts. Okay, yes, Saminathan, yes, the Abhyas test series is online. You can sit at your home and attempt the test. You will get the very good analytical results, which questions you took more time, what was your accuracy, what was your rank with all other students who have attempted the test, everything you can see. Okay, okay. Students' voice is low. Let me just check. Okay, I hope this is audible now. Okay. Okay, so I hope now let's students move to the next question quickly. Question number 3. I am speaking little loudly so that you may not have this problem. Yes, Monu Suresh admit card will be mostly by 7th of April as of the update now. Okay, so we have to wait. Let's move to the next question. The composition of azeotropic mixture of ethanol and water approximately is. So azeotropic mixture, water and ethanol, what will be the combination? Yes, Srinivas has already given the answer. 95% of ethanol and 5% of water. Okay. Okay, very good everyone. Next, this question again very important question. A 5.25% solution of a substance is isotonic. Isotonic means osmotic pressures are same with a 1.5% solution of urea. Okay, so you have taken a 5.25% solution of one substance and it is isotonic with 1.5% of urea in the same solvent. Okay, if the density of both the solutions are assumed to be 1 gram per centimeter cube, the molar mass of the substance will be. Please do this calculation, take 30-40 seconds to solve it. Yes, students, all of you can do it. Please remember the basic formulas. If your fundamentals are clear, you can easily crack this exam. You don't require any very high level knowledge. Basic fundamental formulas which is there in your NCERT book, if that is known to you, you can crack this exam, right? So now see, we know isotonic means what? The partial pressures will be same. So I can see that this first substance pi 1, I will write it. Pi 1 will be equal to pi 2, isotonic. Right, so pi 1 equal to pi 2 means C1 into R into T will be equal to C2 into R into T. Okay, so R and T will get cancelled. Okay, now what we can do, this one, when I'm saying concentration means what? Number of moles by volume, right? Number of moles by volume of the solution. So we just have to see number of moles of 1 should be equal to number of moles of 2. Number of moles is what? Given mass by molar mass. Here given mass is 5.25. Molar mass I have to find out. Okay. Here the given mass is 1.5%, means what? 1.5 gram in 100 gram of the solution. Here 5.25 gram in 100 gram of the solution, right? So 1.5 gram will be there. So that is 1.5 by the molar mass of this one is 60, right? So I want to calculate here M. So that is 5.25 into 60 by 1.5. Okay. So now if I solve this, I can take like this 5.25 into 440 I will get. I'll just multiply. 4 5s are 20, 4 2s are 8, 9, 10, 4 5s are 20 plus 21. Here I have a 0. I'll put 2 decimal places, 210. That is option number C. Sorry, here dear, there is a printing mistake, please. You know urea's molar mass, sorry, typing error, urea's molar mass is 60 gram per mole, okay, 60 gram per mole. Yes, very good. Next, question number 5. This is very easy question. In fuel cells, dash are used as catalyst. What is used as catalyst in fuel cells? Easy question, very easy question. Yes, students, this you can answer quickly. Easy question. Yes, platinum and palladium. Option number B here. Okay. Next, this is again important question. So we have taken little higher level questions because you know this is rank booster series. So yes, definitely little bit on the higher side will be there. Not all the easy questions we have not included. So the first question here now from electrochemistry, in a cell that utilize the reactions, this one, okay, Zn plus 2H plus gives Zn2 plus plus H2. Addition of H2SO4 to cathode compartment will. Please take your time and think about this question. unknown banda. Okay, so here the question, what is the probability of coming questions in KCET from this? So definitely we cannot say that these questions will come, but yes, this concept, whatever questions, formulas I am discussing, similar questions will definitely come. Exact questions may or may not come, but yes, similar questions, same concept based questions will definitely come. So you can definitely prepare these questions. Okay, now let us see, let us write the Nernst equation for this question, right? So I have E of the cell equal to E naught of the cell minus 0.0591 by N log of product side, what is the anion? Zn2 plus, okay, and in the denominator I have H plus square, right? So now what happens when you have H plus concentration? You are adding H2SO4, right? You are adding H2SO4 means what? You are increasing the concentration of H plus, right? See, when I am adding H plus, what I am doing? H plus concentration increases. This denominator term will increase, right? If the denominator term will increase, then what I can say? Log Zn2 plus by H plus, that will decrease, right? If this denominator is increasing, the whole fraction will decrease. That whole fraction will decrease means log of that term will also decrease, this term will decrease. Then now you will subtract a smaller number, okay? You see this whole value will decrease, that means you will subtract from E naught a smaller number, so E value will increase, right? So what will happen? Lower the E? No. Increase the E? Yes. Increase the E? Yes. Lower the E? No. Now if this reaction is at equilibrium, okay, if I add the reactant concentration, I increase, then according to Lee-Chatterley principle, the reaction will try to decrease the concentration of H plus, so that is why it will move in the right direction, right? And shift towards left? No. Shift towards right? Yes. So option number C here. Yes, students, please, I hope that now this is clear what I am saying. Please check. Please check this one. Is it clear? And let me know. I am checking with the voice. Just a minute. Okay. I hope this is clear to all of you. Let me explain once again. Those who are having doubt, please understand once again. This is my Nernst equation, right, for the given reaction. I have increased H2SO4, you have added, means H plus ions will increase. Concentration of H plus increased. This whole factor, when you are increasing the denominator, the fraction value will decrease. This whole term will decrease. This whole term will decrease. Now you are subtracting a smaller number, okay? Now earlier whatever is there, that value now decreased. When you are subtracting a smaller number, E value will definitely increase. So I can rule out option A and D. Now according to Lee-Chatterley principle, when I increase the concentration of the reactants, reaction will try to decrease the concentration, as a result of which it will move in the forward direction or towards right, right? So option number C. Yes, I have explained once again. Please tell me, is it clear? Is it clear? Anyone having doubt? See, very simple. This is Nernst equation. We have increased the concentration of H plus, denominator got increased, fraction value got decreased, this whole term decreased, you are subtracting a smaller number now, so E value will increase, right? Suppose earlier you were subtracting E naught, suppose this E naught is 7, okay, let us take E naught value is 7. Earlier when this was not done, you were subtracting 5, okay, so 7 minus 5 was giving you 2. Now when you added H plus, this value reduced. Now you are subtracting 2 from here. 7 minus 3, 4. So this E value increased or not? Initially it was 2, now it became 4. The connection, so E naught value became 2 to 4. So E naught value has increased. So that is why B and C can be the correct answer. Now according to Lee-Chatterley principle, when the reactant concentration increases, reaction will shift in forward direction. So that is why shift towards the right. Yes, everyone is clear? Next, question number 7. Question number 7 here. Aluminium displaces hydrogen from acid but copper does not. A galvanic cell is prepared by combining copper and aluminium, which has an EM of 2.0 volt at 298 Kelvin. If the potential of the copper electrode is 0.34, then that of the aluminium electrode will be? Yes. Please try this question. See, what I can say, aluminium displaces hydrogen, right? Means aluminium is more reactive, okay? Aluminium can undergo oxidation. Copper will undergo reduction. So what will be my cell look like? Aluminium on the anode side and copper on the cathode side. So what is E naught of the cell? Cathode minus anode, E naught of copper minus E naught of aluminium. Okay, E naught of the cell is already given to me as 2 volt. E naught of cathode is 0.34 minus E naught of aluminium I have to calculate. Okay, so if I get that 0.34 minus 2, that I will get 10 minus 4 6, 9 minus 3 6, right? I can just subtract it for all of you. So I will get 1.66 minus 1.66 volt. Okay, students, you will get minus 0.034 minus 2, right? Not A. It's not B. It's A. Any doubt here? Simple question from your nursed equation. Please put a thumbs up if this is clear. Question is clear. Just students, please type the question number 7 and a thumbs up to show that this question is clear to all of you. 7 and a thumbs up you can give me quickly if it is clear to all of you, or yes, that hands print is also good. Ashwini, yes, all of you are clear. Fine, fine, fine. Let's go to next question number 8. Same amount of electric current is passed through the solutions of AgNO3 and HCl. If 1.08 gram of silver is obtained in the first case, the amount of hydrogen liberated at STP in the second case is? Very good question again. You are giving same amount of current. Whenever this term comes, okay, same amount of current, quickly thinks about, you have to quickly think about Faraday's second law. Okay, same amount of current means Faraday's second law. Okay, so we have been given with same amount of current is passed and I have 1.08 gram of silver. Then what is the amount of hydrogen liberated at STP in the second case? Please solve this. Take some time and solve it. Okay, now see quickly, if I have this one, I know Faraday's second law. Faraday's second law. What is it? M1 by M2 is equal to equivalent weight of 1 by equivalent weight of 2, right? And what is the formula of equivalent weight? Equivalent weight is equal to molar mass by n factor, where n is the number of electrons used. Okay, so I have here, I will write mass of hydrogen by mass of silver, okay, is equal to equivalent weight of hydrogen by equivalent weight of silver, right? I'll get this as the formula. Yes, now see, this much clear to all? Okay, now all of you see, I have to calculate mass of H2 first. Mass of silver deposited is already given to me, 1.08. Equivalent weight of silver, how can I? Equivalent weight of hydrogen. So hydrogen, how does it reacts? 2H plus 2 electrons gives me H2, right? So equivalent weight will be what? Equivalent weight of hydrogen, molar mass of hydrogen is 2, 1 plus 1 2, number of electrons used is 2, so that is 1. Clear? Equivalent weight of hydrogen is 1. Similarly, if you see silver, how does silver forms? Ag, right? So here equivalent weight of silver will be what? Molar mass of silver 108 divided by n. How many electrons are used? 1. So 108. So I have 1 by 108. Okay. Now I think we can calculate this one. So mass of hydrogen will be 108. I multiplied this one on this side, 1.08 by 108. Okay. So I will get a 0.3 0.01. Okay, 0.01 grams. Clear? Now this is what? This is, I got mass of H2, right? This is not the volume of H2. You have to calculate the volume of H2. We have now completed up to mass of H2. Now let us calculate the volume of H2. Okay. Let us see the next one. Yes, I have already found students getting the answers here. So I have got of H2, right? All of you are clear up to this. Mass of H2 I got 0. So 0.01 gram of H2 is deposited. Now what is number of moles of H2? Given mass by molar mass 0.1 by 2. Now volume of H2. So volume of H2, 1 mole occupies 22,400 ml. So if I want to calculate for this one, 0.01 by 2 into 22,400. Okay, so I will get 11200, that is 112 centimeter cube. Students, please put the question number and answer. Please put the question number and then you put the answer. Yes, Saminathan, definitely. Once again, I will explain. See here, very simple question. We have to use Faraday's second law. Clear up to this term, Faraday's second law. What does Faraday's second law tell you? Mass of 1 by mass of 2 equal to equivalent weight of 1 by equivalent weight of 2. Here what all compounds I have, you can see same amount of electric current is passed through the solutions of AgNO3 and HCl. So imagine like this, see, in this you have AgNO3, okay, and in this you have HCl, okay, and you are giving same amount of current to both the cells. Okay, same amount of current is given in both, same amount of current for same time you have given. Here the mass deposited of silver, what will happen? Silver will deposit at the cathode and here hydrogen gas will form. So here mass of silver deposited is 1.08 grams. Now we have to calculate what is the volume of hydrogen produced here. Okay, that we have to calculate. So what is our formula? When same amount of current is passed through both of them, we can use Faraday's second law. So I can say that mass of H2 will by mass of silver will be equal to equivalent weight of H2 by equivalent weight of silver. Okay, so now mass of H2 I want to calculate. Mass of silver deposited they have already given in the question, 1.08 gram. Equivalent weight is what? Molar mass by N factor. Hydrogen, how does hydrogen get deposits here? 2H plus 2 electrons gives me H2, right? So what will be the equivalent weight of hydrogen? Given molar mass of hydrogen is 2, number of electrons is 2, so it is 1. So equivalent weight of hydrogen is 1. Silver is how much? Silver, how does it react? Ag plus 1 electron gives you Ag, right? Molar mass of silver is 108, N factor is 1, so equivalent weight is 108. Now if I solve this, I will get that the mass of hydrogen is 0.01 grams. Okay, but the question is asking us to calculate the volume of hydrogen, right? So volume of hydrogen I have to calculate. Okay, so you know always at STP 1 mole occupies 22,400 centimeter cube. Okay, 1 mole of any gas. Okay, 1 mole of any gas at STP occupies this much volume, right? So now I have what is the number of moles. See, if I have mass, I can calculate number of moles. Number of moles of H2 is given mass by molar mass 0.01 by 2, right? Number of moles of H2. Volume of H2 will be, see, 1 mole occupies this much. 1 mole occupies this much. Then these many moles will occupy how much? Just simply multiply 0.01 by 2 into 22,400. I will get 112. Right? I'll get 112. Yes, I hope this is clear. Please students, put a thumbs up or any palm symbol to let me know if this is clear to all of you. Quickly. Any doubt? Please you can ask. Is it clear? Okay. Okay, that's good. Then let's move to the next question. Which of the following conditions will increase the voltage of the cell represented by the equation? You want to increase the voltage, okay, means you want that the cell, you are making certain changes here according to the option, in which case the voltage will increase. This type of question I have already discussed in that previous question, previous question. First write down the cell value. E value will be equal to E naught of the cell minus, so I have product divided by reactant, right? So on the product side I have copper 2 plus ions, and on the reactant side I have silver ions. Now please think this question. Yes. So students, tell me, how can I increase the E naught value? You have to increase the E value. So for increasing E value, just now we have solved. If I see, if Ag2 plus concentrations, if Ag plus concentration will increase, this fraction will decrease, right? This fraction will decrease, then this total value will decrease, and you are subtracting a smaller number from this one, right? You are subtracting a smaller number from this one, so E value will increase. So what we have to do? Ayush Rao, okay, so Ayush Rao, last step. Okay, first let us do this question, then I will go for the previous question. Ayush, please wait. So what I have to do? I have to increase the concentration of Ag. If I increase the concentration of Ag, this denominator, this fraction will decrease, or overall this one will decrease, and E naught value will so E value will increase. So I can do what? Increase the concentration of Cu2 plus. See, if you increase the concentration of Cu2 plus, this fraction will increase, this whole value will increase, and you will subtract a greater number from E naught Rao, right? So that means E value will decrease, but I have to subtract a smaller number from E naught. Okay, if I want to subtract a smaller number, Cu2 plus concentration should decrease and Ag plus concentration should increase. Okay, so I have increased the concentration of Ag plus ions, that is option number D. Okay, students, I hope this is clear. All are getting this one? Okay, next question. Yes, try this question, 10th one. Please try this question. Let me have some water. Try this question number 10. All of you, please solve it. Okay, conductivity is given. Okay, please write down what all data are given to me. Conductivity of the solution is given. Then I have molar conductivity, okay, you want to find, we know this formula, right? Molar conductivity equal to kappa into 1000 by C, right? So first let us find out this C value. What will be C value? Kappa into 1000 by lambda naught M value. So kappa value is how much? 1.85 into 10 to the power of minus 5 into 10 to the power of 3 divided by molar conductivity is 140 into 10 to the power of minus 4. Okay, so I got 5 minus 3, here it is minus 2, it goes up, so I will get 1.85 minus 2 plus 4, 10 to the power of 2 by 140. So I can write it like 185 by 140, right? Clear this one? So this is my concentration. Okay, so if I solve this, how much I can get? 5 2s are 10, 28, and here I have 5 3s are 15, 27, right? 5 7s are 35. Yes, 37 by 28. So how much is 37 by 28? Small numbers, we can easily divide it. So I can go now 28, 4 8s are 32, 4 2s are 8, 4 I cannot take, 3 8s are 24, 3 2s are 6, 7, 8. So 3 8s are 24, 7, 8. So 1.3 I got, right? 1 second, anything, let me check the calculation. 1.8 into 10 to the power of minus 5 kappa into 1000 by molar conductivity is 140 into 10 to the power of minus 4. So 5 minus 3, it gone minus 2, goes up, minus 2 plus 4, I have this one, and I have this one 1.85 by 140. Okay. Okay, I think here we have done a small mistake. So students, please see here. Yes, one small mistake, students. You see, the units are given in meter, right? When the units are given in meter, what is the formula? Molar conductivity equal to kappa into C by 1000. Okay, please remember, if the molar conductivity is in centimeter inverse, then it is kappa into 1000 by C. But if it is in meter, it is kappa by C into 1000. So I have a small mistake. So I will calculate here kappa divided by molar conductivity into 10 to the power of minus 3. Okay, now let us quickly. Kappa value is 1.85 into 10 to the power of minus 5 into 10 to the power of minus 3 divided by 140 into 10 to the power of minus 4. So 5 minus 3, it is minus 8. This is plus 4. So 1.85 by 140 into 10 to the power of plus 4. Now I can use it like 185 by 140 into 10 to the power of 2, right? Then also, okay, just a minute. I have this one, 1.32 into 10 to the power of 2. Yes, Purti, 1000 will be in denominator, right? So I have taken kappa into lambda m by into 10 to the power of minus 3, 1.85 into 10 to the power of minus 5 into 10 to the power of minus 3 divided by 140 into 10 to the power of minus 4. Okay, so now I got this one. After that, what I can do, this is your C value. Okay, now you want to find the what I have to find, KSP. Okay, so KSP for this type of salt is S square. So I have to take 1.32 into 10 to the power of 2, its square. Okay, so I will get 1.74 into 10 to the power of 4. Okay, so I think there is some error in this powers. Okay, I will check this part once again, but the answer you can see, the most probable answer will be option number D. Once again, I will check the calculation and the values given, and I will put in the comment section. Okay, there is somewhere I think some error is there. This is minus 8, it goes, it becomes, okay, here it is minus 8 and then plus 4. So minus 4 here. Okay, okay, small, I have done so many calculation errors today. So I have minus 4, and this one I can make an correction. 185 by 140 into 10 to the power of 10 to the power of 2. So I will get minus 2, then I will get minus 4. So I will check this calculation error, students. Please do not worry. I will put in the comment section. You can see it. Okay. Okay, this part I am just leaving, but answer will be D because 1.74 I am getting, but I will check this calculation. This is power part. Okay. Move to the next question here. The mass of glucose that should be dissolved in 50 gram of water in order to produce the same lowering of vapor pressure as produced by dissolving 1 gram of urea in the same quantity of water is? Please try this question, take 1 minute. Mithun, I can understand. See here, Mithun, we have taken little bit on the upper side of the questions. Please try to solve these questions. Definitely you will understand. If you have any doubt, please put down in the comment section. I will address to it. These are not very easy question. I told you it is a rank booster series. So we have knowingly taken certain difficult questions which is asked in the your KCET examination. Okay. Yes, please try the next question. Please try this question. Please read the question, know all the formulas that you have written, and then see, if I give you just easy questions and I make you happy that yes, you can solve all the questions, that makes no point, right? It's time to do certain difficult questions because in exam it will be asked, so we have to be ready for that. Okay. Yes. The mass of glucose that should be dissolved in 50 gram of water in order to produce the same lowering of vapor pressure as is produced by dissolving 1 gram of urea in the same quantity of water. Can you think? Please take some time, solve the question. I am giving you time, 1 or 2 minutes. Take your time and solve it. All of you, please sit with your notebook and pen, write down the values, take 1 minute, 2 minute time and solve it. See, case 1. What is there? Relative lowering of vapor pressure. You are dissolving what? Glucose. Due to glucose, whatever, so I can write mole fraction of glucose. And we will have mole fraction of urea. These two quantities are same, means we want the same relative lowering of vapor pressure for mole fraction of glucose and by dissolving urea. Okay, so I can write that then mole fraction of glucose will be equal to mole fraction of urea because this is equal, right? See, so you just imagine you have two containers. Okay, here I have water, here also I have water. When you add a solute, vapor pressure decreases. So here in the first case you added glucose and here you added urea. Okay, so the question is saying that the decrease in the vapor pressure or the relative lowering of vapor pressure in both the case, that is P by P naught, is same. This one and this one, the P naught, the decrease in vapor pressure is same. If the decrease in vapor pressure is same, means the left hand side of the equation is same, then the right hand side of the equation will also be same. Mole fraction of glucose will be equal to mole fraction of urea. Now what is mole fraction of glucose? Number of moles of glucose by number of moles of water, right? In this type of formulas we do not consider, in relative lowering vapor pressure questions you do not consider the denominator number of moles of solute. Why? Because it is very less compared to the number of moles of water, and here it will be number of moles of urea divided by number of moles of water. Okay, so I can cancel these two. Okay, now number of moles of glucose will be what? That I have to calculate. 1 second. Yes, so number of moles of urea, how much urea I have dissolved? 1 gram, right? 1 by 60, that is number of moles of urea. Glucose mass is this one by 180. Okay, so if I solve this one, how much I will get? 180 by 60, that is 3 grams. Yes, yes students, please tell me if this is clear. Please see the question and tell me if this is clear. Please see the question, very simple. We are dissolving two solutes, okay? And I am saying that the vapor pressure, the decrease in vapor pressure here and the decrease in vapor pressure here will be same. If both the vapor pressures are same, then I have mole fraction will also be same. Mole fraction of glucose will be equal to mole fraction of urea. Now you see we have given same quantity of water. Same quantity of water is taken, means number of moles of water will also be equal. Number of moles of glucose will be equal to number of moles of urea, right? So W by 180 equal to 1 by 60. means 180 is what number of moles of glucose, given mass by molar mass, here given mass by molar mass. So I will get W equal to 3 gram, so option number B. Please tell me if this question is clear to all of you. Just put a thumbs up for me or any heart shape, anything, just show me. Please let me know if this is clear to all of you. Sneha, good. Sneha, I understand, definitely this is difficult, but it is not very difficult that you cannot solve it. It is just that we have not given very direct question, these are little bit indirect question. But tell me, any formula is there in this question which we don't know from before? All the formulas are known to us, right? But the question has been asked in a little tricky format, in a different format, so that we can get stuck or we can get confused. But if we practice this type of questions, we will definitely can do better in the exam, right? Okay, once again Kavya. Kavya, see here, very simple, we have same relative lowering of vapor pressure. This is the relative lowering of vapor pressure formula. If LHS equal, RHS will be equal. Mole fraction of glucose will be equal to mole fraction of urea. Number of glucose by number of moles of water will be equal to number of moles of urea by number of moles of water. We have same quantity of water is taken, so number of moles of water is also equal. Remove that. Number of moles of glucose will be equal to number of moles of urea. So we have here given mass by molar mass, here also given mass by molar mass. You can see 1 gram of urea is taken, 1 gram of urea. So given mass by molar mass, given mass by molar mass. So I have to calculate this given mass of glucose, which is 3 gram. So if I dissolve 3 gram of glucose and 1 gram of urea, 3 gram of glucose in 50 gram of water, and here also 50 gram of water, the relative lowering of vapor pressure will be same in both the solutions. Clear? Yes. Next question. Okay, let's do sudden easy question. Which of the following aqueous solution has the highest freezing point? I want yes, so can we have this answer quickly? Where the freezing point will be highest? Please see the question properly. Put with question number. I want the answers with question number, students. With question number. Sunita, Sneha, Spurti, please put down the question numbers. Yes. 12A. Many of you are saying A. Okay, let's do. See here, you know that aqueous solution is there, right? What is the freezing point of water? 0 degree Celsius, right? Freezing point of water is 0 degree Celsius. Now when you see these are all 0.1, okay? All the concentrations are same. So I know delta TF is equal to I into KF into M. So molality is same for all. So I value I will check. So for the first one, I have 5 ions. You can see 2 aluminium and 3 sulfate. So I value is 5. So this one will go up to, suppose option A. So the decrease is by 5. Okay, 5 I have mentioned here. Here I have 2 plus 1, 3. I value is 3. So here it will be somewhere around this one, that is 3. Okay. Now if you see AlCl3, I value is 4. So here it will be 4. Okay, so that depression I am saying, okay, here this one will be the boiling point, freezing point, here this one and here this one. Now you see NH4Cl, I equal to 2, so this one will be up to here. This is option A, this is B, this is D, where it is 2. So now you see where the freezing point is highest. The freezing point is decreasing, right? Here in option number A, there is maximum decrease in the freezing point. So this one is the lowest freezing point. You see 0 was there, suppose this is -1, -2, -3. So this will be in -3 somewhere. This one is the least decrease. So here the freezing point will be maximum. So option number D, okay? Those who have answered D, that is correct. A is not the answer, D is the answer, okay? Yes. Okay, next question number 13. Please try this question. This is a good question. Please try this. A hypothetical reaction A2 plus B2 gives 2AB follows the mechanism given below. The order of the reaction by RDS method is, rate determining step method is. Please try this question. multiplex Thor 2M. Ashwini ma'am, when Comet K series will launch? Dear, give us 1 or 2 days. We are going to launch it very soon. Already the crash course is there. If you want to purchase this, link is there in the description section. Please go and purchase a crash course. Entire thing will be covered there. Okay. But we have the YouTube free batch as well. As I told you from before, we will be launching it soon. Okay. Maybe today or tomorrow. Just 1 or 2 days we will be launching it. Okay. Yes, I want all of you to answer. Try this question. 13th question. Please try this question. 13th one. See, always remember the rate. Rate is determined by slowest step. Okay, slowest step. So if you see in this reaction, this is the slowest step. So I can write that rate is equal to K into A into B2. Right? This is the slowest step possible, or this can be the rate law. But if you see the reaction that is given to me, A2 plus B2 gives 2AB. Right? This is the reaction given to me. In this reaction, in this entire reaction, there is no mention of the term A. Right? There is terms are what? A2, B2 and AB. There is no term A. So that means what? A is an intermediate. It is formed in the reaction and it is decomposed in the reaction. So I cannot have A in my rate law. Rate law is what? It is related to the reactant's concentration. But A, you can see there is no term A here. So I have to, what I have to do? I have to modify this equation. So I can take the first equation, you can say equilibrium, right? So I can write K equilibrium is equal to product concentration, right? Product concentration divided by the reactant concentration. So I can write that K equilibrium into A2 is equal to A square. Okay, I'll take square root on both sides. So K equilibrium into A2 is equal to A. Now I will put this value of A here. Okay, so if I write now rate equal to K into, what's the concentration of A? K equilibrium 1 by 2, okay, into A2 also to the power of 1 by 2, and I have the previous one B2. Okay, now this is also a constant, this is also constant, this together can form a new constant K dash, and I have A2 1 by 2 B2. Okay, so what is the overall order of the reaction now? Now you can see that the rate law contains A2 and B2, okay, which is actually there in the reaction. So I have 1 plus 1 by 2. So I can say that the order of the reaction is 3 by 2. 1 plus 1 by 2 is 3 by 2, which is 1.5. Okay, so option number C here. Yes, 13C, all of you are getting correct. Yes, 13A will not be there, dear. See, as I told you, what is the problem in this equation? This equation contains A, and A is not a part of a reaction, right? So we cannot express the rate law with something which is not a part, which is not there in the final equation. So that is why we have to modify this one. We can say this is an equilibrium reaction, so we can write the equilibrium reaction, get the concentration of, get the value of A in terms of A2, and once we get this, we can substitute and get the 3 by 2 value. Okay. Yes. I hope this is clear. Okay. Next question. I hope, please students. Okay, Mangala Naik once again. Okay. Dear C, slowest step determines the rate law. So slowest step there is A and then B2. This is the rate law I will get. There is a problem in this equation. This A which I have written is not there in the final equation, right? This is the final equation. In that there is no A term. There is A2, but there is no single A term. So that is why I have to express this A in terms of A2. So you can see this equilibrium equation. I will write K equilibrium is what? Product concentration divided by reactant concentration. Next, I will multiply this one, this side, I will get this one, and I will get the value of A. So now what is the value of A here? A equal to K equilibrium 1 by 2, A2 1 by 2. Okay, that now you can see that I have got this A in terms of A2. Now just I have to substitute this value here. So it was K, and for A I substituted this value, equilibrium half root over of A2, and B2 is there, which is already there in the equation. Now I can just take this whole constant as K dash 1, this is also one constant, this is also one constant, then A2 half and B2. Now if I add both of them, the order will be 3 by 2. Okay. Yes. Next, question number 14. This is simple question, all of you please do it. Please do this one, simple one, all of you can do it. Half-life of a substance A following the first order kinetics is 5 days. Starting from 100 gram of A, the amount left after 15 days will be. Krishna Lover, ma'am, question number 12, freezing point highest they asked. Yes dear, highest freezing point. See, depression was happening, right? Highest. So when your depression is happening, the option number A, where the maximum depression is there, that will have the lowest freezing point. And where there is less freezing, less depression, which was your NH4Cl, I value was 2, there it will be the highest freezing point. You see, depression, this is not boiling point, freezing point, right? If boiling point would have been asked, then the first option, that is aluminum sulfate, would have been the answer. But here there is decrease. The I value is more, means there is, it was 0 degree. Now here it decreased to this value, like -5. Where it is NH4Cl, it is -2. It from 0 it became -2. So you can see the decrease, the now -5 is greater or -2 is greater. Highest is -2, right? So that is why. Yes, now here 100 gram of A left after 15 days. Okay, see now, see, half-life is 5 days. So 100 after 5 days will become 50. After another 5 days will become 25. After another 5 days will become 12.5. So 15 days it will become 12.5. Option number C. Okay, next question number 15. Yes, question number 15. If 6.25 of a substance is left after 240 minutes in a radioactive decay, then what will be the half-life? Please try this question. If 6.25% of a substance is left after 240 minutes, okay, after 240 minutes, 6.25% is left, then what is the half-life of the compound? Very easy question. Please try this question, all of you. Students, please try this question, all of you. No problem, topper, monkey. If you feel bored, you can leave, no problem. Okay. But yes, this is the point, this is the time where we have to work hard. Okay, so that is your wish, dear. You can do, if you are not, if you don't want to study at this last 15 days also, then you, I don't know when you will study. Okay. Organic chemistry, you can expect, dear, 15 to 20 questions. Okay, 20 questions you can easily expect. Tell me this answer quickly. You are asking which is not required, which questions we actually required. Please do that and tell me. So I got one answer, 60 minutes from Anbu and Chinamma. Okay, see, so 6.25%, I started with 100%. Okay, then with first T half, how much it will become? 50. Then after another T half it will become 25. After another T half it will become 25, 12.5. Then after another T half it will become 6.25, right? So how much we have? 1, 2, 3, 4. So total 4. Okay, so 4 half-lives are there. Total this time is 240 minutes, right? From here to here it total took 240 minutes. Then each one will take how much? 240 divided by 4, 60, 60, 60 and 60. Okay, so half-life is option number A, 60 minutes. Those who are saying 60 minutes, that is correct. Okay, yes. Next, question number 16. This is a previous year question from 2023. Okay, please see this question. That the rate constants K1 and K2 for two different reactions are given. Okay, the temperature at which K1 is equal to K2. I think all of you will be able to do this question. We have solved this question many times. Many times I have solved it in top 30, in your previous year questions, in tests. Many times we have solved this question. Please try this question. Now see, the rate constants are given K1 and K2. You have to find the temperature at which K1 and K2 will be equal. That's easy, right? We can just say K1 is equal to K2. Okay, let it be equal. What's the value of K1 given to me? K1 is 10 to the power of 16 into e to the power of minus 2000 by t. And what's the value of K2? 10 to the power of 15 into e to the power of minus 1000 by t. Now what we have? We have two equations. We have to solve it. So I can divide this term on this side. So I will get 10 to the power of 16 divided by 10 to the power of 15 into e to the power of minus 1000 by t divided by e to the power of minus 2000 by t. Now this one will give me 10. Okay. Now this one minus 1000 by t. If this goes up to plus 2000 by t, so I will get e to the power of minus 1000 by t. This goes up plus 2000 by t. So I will get e to the power of 2000 minus 1000, that is 1000 by t. Now this side it is 10. Now let us take ln on both sides. So ln of 10 is equal to 1000 by t, right? Ln of anything to the power of x, you should know this. Ln of e to the power of x is equal to x. So if I take ln of e to the power of 1000 by t, it will give me 1000 by t. Now ln of 10 is not, we don't know the value, I will convert it into log. So to convert ln to log, you have to multiply with 2.303. Right? So I will get log 10 value is 1. So I have 2.303 into is equal to 1000 by t. So what is t value? 1000 by 2.303 Kelvin. Okay? Yes. This all of you have answered. Krishna, it is C. Sneha, C. Moni, yes. Yes. All of you are getting correct. Yes, this is a previous year question. See, it is, we know this formula, right? But we direct questions are not asked. So little bit on the higher side we have to practice, dear. Okay? Next question number 17. A first order, this is also easy question. A first order reaction is half completed in 45 minutes. Means T half is given to me 45 minutes. Okay? Then how long does it need 99.9% of the reaction to be completed? This is, you can solve in within seconds if you know one relation. What is it? We have derived it also. T 99.9% is equal to 10 times of T 50%. We know this. So I know for completing 50%, 45 minutes is required. So for completing 99%, 10 times of T 50, 45, 450 minutes. Right? But the answers are in hours. So we can convert it into hours. So that means divided by 60 minutes. So I will get 6 7s are 42. Then I have 7.5 hours. So that is option number D here. Okay? Yes, all are getting this one. Very good. Next question number 18. This is very, very important question. It is a previous year question of 2023. Okay? Important question, very important question. Please try this question for 1 minute. Read the question. Don't get nervous by seeing the length of the question. Please do not worry. Read the question one by one and note down all the values. How many of you have solved this question before? You can put a comment here. If you have solved this question before, just give me a thumbs up because this is a previous year question. Okay, so I hope many of you would have done by this time also. Yes, Amir Raj is telling has already done. Okay, please solve this question. All of you, please take 1 minute time and solve. Yes. All of you are solving? It will take time. Please solve, everyone. It will take time. Okay, let's solve it. Okay, let's start solving. Please solve with me so that you don't left behind. So what I have, see, you have 5.85% of AB and 9.5% of XY2. 80% dissociation is there for AB, 60% dissociation is there for XY2. Okay, let's solve this question. See here, I have two solutes, AB, okay, and XY2. Okay, for AB, what is the mass given? 5.85 gram. Okay, and for this one it was 9.5%, means 9.5 gram. Molar mass of AB is 58.5 and molar mass of this one is 95. Okay, so now can I calculate number of moles of AB? Number of moles of AB, that is what? Given mass by molar mass, right? So that is 0.1. I'll get 0.1. Just a minute. 1 by 100. This is 10 by 100. Yes, 0.1 I will get. And here also number of moles of XY2. 9.5 by 95. That is again 0.1. Okay. I got both number of moles. Now what is I value here? For alpha, if you see the alpha value, that is for this one, the degree of dissociation is 80%, right? Alpha is 80%, means 0.8, and here the value is how much? 60%, 0.6. Now we have to calculate the I value. I value is what? If you remember the formula for dissociation, we have alpha is equal to I minus 1 by n minus 1, right? Alpha is 0.8, I value minus 1, n value, how much ions I will get? 2 minus 1. Okay, so I will get I equal to 1.8 here. Okay, I is 1.8. Now here if I see I is equal to alpha is equal to 0.6. Okay, alpha is equal to 0.6, so we have alpha equal to I minus 1 by n minus 1, so 0.6 I minus 1. Here number of ions I am getting is XY2, that is 3, so 3 minus 1, that is 2, right? 2 into 0.6, 1.2, 1.2 plus 1 is 2.2. Okay, so I got I value here, I got I value here. Okay, okay. Question not understanding. Okay, I'm simplifying the question for you first. See, just a minute. See, you have a sample of water. Okay, let's understand the question first. Those who didn't understand the question, look at this question. You have a sample of water which contains two solute. You have AB solute here and two solute. You have added 5.85% solution, means you have taken in every 100 gram there is 5.85 AB, that type of solution concentration is there. So AB concentration is 5.85, XY2 concentration you have taken, which is 9.5%. okay, now these are ionic solids, they will dissociate, but they are not undergoing complete dissociation. Okay, so they are not undergoing complete dissociation. So what will happen here? Okay, just a minute. Okay. Okay, so students, the video is fine now. Sorry for the interruption. So you see, you have AB and you have XY2, right? You have AB and you have XY2. 5.85 gram of AB you added, 9.5 gram of XY2 added. These are electrolytic solids, means they will dissociate. So AB dissociated how much? AB dissociated 80%, okay, and XY2 dissociated 60%. Okay, so now we have to calculate, when you add solute, the boiling point will be, sorry, the freezing point will decrease. So we have to calculate the freezing point of this solution, where AB is added and XY2 is added. What will be the freezing point of that solution we have to calculate. Okay, I hope this is clear now. The question is clear. So now what is the formula for freezing point? You can see we have the formula for freezing point, that is Okay. Now freezing point formula is what? Delta TF is equal to KF into I into KF into M, right? This is when you add one solute. Here we have added two types of solute, AB and XY2. I have added two types of solute. So it will become KF into I1 M1 plus I2 M2. Okay, this is the formula when you have two different types of solute. Okay, now we will do a very simple calculation. See, I want to calculate the molality. Okay, so molality I want to calculate for this one. What is the formula for molality? Let me calculate here. Okay, what is my formula for molality? Molality is equal to number of moles, that is 0.1, right, divided by 1000 by mass of the solvent. Okay, now mass of the solvent, what I will do is I will keep it as 100 gram only. Why? Actually, what is the mass of the solvent? See, 5.85 gram is solute. Okay, 5.85 gram is solute. Total 100 gram is solution. 5.85 gram is solute. So what is the mass of the solvent? 100 minus 5.85, right? But for easy calculation, I am keeping it as 100. But actually how much it will be? Actually this value should be 100 minus 5.85, which is equal to 10 minus 5, 5, 9 minus 8, 1. Then I have this side 4 and 94.15 should be the actual value. Okay, but for easy calculation I am taking 100 grams. Okay, for easy calculation. Now if I solve this, I will get molality equal to 1. Okay, now similarly if I see here, molality will be equal to number of moles into 1000. Okay, by 100 again I will take here for easy calculation. Why? Actually what is the mass here? If you see 100 minus 9.5, right? So that will be equal to 90.5. Yes, so actually it should be 90.5, but for again easy calculation I am taking it as 100. So I will get here molality as 1. Okay, now you see actual value. So actual value of this 100, this is not actually 100, right? This is actually is how much? 94.15. So I should get, if this is 94.15, this value has decreased, actual value, the molality value, actual molality will be greater than 1, right? If this value is less, then I will get greater than 1. Similarly here, the molality actual will be greater than 1. Okay, but for easy calculation I am taking it as 100 and 100. Now let us solve this value. Kf value is given to me. Kf value is given to me how much? Let me see. 1 second. Just a minute. Kf value is 1.86. Okay. I1 value is how much? 1.8. Okay. M1 is 1 and this one is 2.2. Okay, just I will add this one. So 8 plus 2, 10, 2, 3, 4, right? 8 plus 2, 10, 2, 3, 4 into 1.86. Multiply 4 6 are 24, 4 8 are 32, 33, 34, 7.44, right? 0.7, sorry, 0.744, 4 I got, 4 6 are 24, 32, 37, yes, 7.44 I got. Okay, 7.44 I got. Now what is the value? TF 0 degrees Celsius, or I think the values are given in 273. So let me take it in Kelvin. So I got delta TF is equal to 7.44, means 273 minus T naught F, 273 minus TF is equal to 7.44. So if I subtract this one, 273 minus 7.44, how much I will get? 273.00 minus 7.44. 10 minus 4 6, 9 minus 4 5, then 12 minus 7 7. I will get 270. Okay, 265.656. Okay, this I will get. But here is a catch. Please understand this one properly. Actual value, if I take, see, if I take molality equal to 1, then I will get this value. If I take molality equal to 1, okay, but actual molality I told you already, it is greater than 1, right? Molality is greater than 1. See, where is this? This molality, if I take 1, then I am getting 7.44. But molality is greater than 1. right? But for easy calculation I have done this one. So but molality is greater than 1, that means this 7.44 is not the correct value, it will be somewhat higher, right? So when you are subtracting this one, so this value is, you are subtracting a bigger number, so the value should be actually less than 265. Are you getting this one? Are you getting this one, what I am saying? All of you please understand this one. I am saying that if your molality is equal to 1, then you are getting this value, okay? But our molality is not equal to 1. Why? Because I have done these assumptions for calculation. The actual molality is more than 1. If actual molality is more than 1, this value will be also more. So if this difference that you are calculating, this will also be more than 7.44. So you are subtracting a bigger number now. So it will be less than 265.56, right? So which option we have less than 265.56? See, 1 second. Yes. So 265.56 I will get if I take molality equal to 1, but that is not correct. Any value less than 265.56, that is your option number C here. Clear? Yes. I hope this is clear. Next question number. Okay, we'll go to some coordination compounds. Now I think you will be able to answer quickly. Which of the following complexes is an outer orbital complex? Outer orbital means you need sp3d2 hybridization. Which is an outer orbital complex? Please try this question. Yes, Ayush, if you see, Ayush, please listen, we have two series. One is your top 30 series, okay, top 30 question series, and this rank booster series. If you watch these two series and do question practice, you can easily score very good marks. 40 plus you can easily get in chemistry, okay? Now all of you answer this question. Outer orbital complex. Outer orbital complex. Outer orbital complex. Let me show you nickel, okay? What is the electronic configuration of nickel? 3d8 4s2, right? Nickel here charge is 2 plus, so its configuration is 3d8, right? So I have here, okay, 1 2 3 4 5 6 7 8, okay? Now this is a very strong field ligand, pairing of electrons will take place. So this electron will get excited, okay, will get excited, and if I want to pair up here, so this electron will come here. But see, for coordination number 6 we need d2sp3 hybridization, means 2 inner d orbitals are required. But here because it is already 8, I can have only 1 vacant d orbital. So there is no use of doing any pairing here because I am not able to get 2 vacant d orbitals. So that is why what will happen here, there will be no pairing taking place, and here we will use 4s, 4p and 4d. So sp3d2 hybridization will be here option number D, okay? Clear? Those who are saying A, is it clear? See, what is the problem with A? Cobalt, right? Cobalt 3 plus is 3d6, okay? Now 3d6 if I have 1 2 3 4 5 and then 6. Now pairing of electrons will take place because NH3 is a strong field ligand. Pairing of electrons will take place, right? So I have here what? D2 or sp3 hybridization will take place because I have 2 d orbitals free. So here hybridization will be d2sp3. So it is a inner orbital, okay? Question is asked for outer orbital, okay? I hope all of you are getting. Tell me, is it clear to everyone now? See, if you take this one, nickel, if you take nickel, you can, if you pair up also, you will get only 1 vacant orbital. We have no use with 1 vacant orbital. We need at least 2 vacant orbital for d2sp3 hybridization, right? But here, if I am doing, I am getting only 1. So why to waste energy there? Later, it's anyway, if I pair up also, I am not able to use it, right? So that is why there will be outer orbital complex. Yes, all of you are getting this. Very good. Next question number 20. Okay, nickel combines with a uni-negative monodentate ligand X minus. Okay, so nickel combines with X minus to form a paramagnetic complex which is NiX4 2 minus. The number of unpaired electrons in the nickel and the geometry of this complex ion are respectively. Okay, can you think? Nickel is forming a paramagnetic compound NiX4. So paramagnetic means there should be unpaired electron. Monovalent. So what is the nickel? The X charge is minus X, right? So what is the nickel electronic or oxidation state here? +2, because X minus 4 minus 2, I'll get nickel +2. That means 3D8. Okay, it will be 3D8. Now you see, let me see if anybody have answered this one. Anybody has answered this one? Let me see. Please answer this one. So we have so D8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now you see it is saying that if I say that I can pair up this one, if I pair this electrons, then it will no more remain a paramagnetic complex, right? But the question is saying that it is a paramagnetic complex. So that means X is a weak field ligand and there is no pairing of electrons here. Okay. So this is my 3D. I will go for 4s and 4p. Okay. So hybridization will take place here. sp3 hybridization will take place. So I will get 4 new sp3 hybrid orbitals where this X can form the bond, right? So you can see I am getting it is a paramagnetic complex. So definitely I have how many unpaired electrons? The number of unpaired electrons will be 2. Definitely 2 unpaired electrons in the nickel, and the geometry of the complex ion. Geometry, if you see, what is the hybridization? sp3. For sp3 the geometry is tetrahedral. So option number A. Yes, those who are saying A, they are absolutely correct. Okay. Now let's go for the next question. Yes, this is easy question. Please answer. Ayush, absolutely correct. So whenever you have M, A, B, C, D type, you will get C. You can take M on one side, B on one side, C and D like this. Another you will get M here with respect to C, and you can keep B and D here. Then you have one more where M and you have D and you have B and C here. So these are what? 3 geometrical isomers. Out of these 3 geometrical isomers, 2 is we have cis and 1 is trans. Okay, so option number D. Yes, those are saying D, absolutely correct. Next, is this question visible to all of you? I think it is visible. Let me check. Okay, your question is the order of wavelength of light absorbed in the complex ion. Okay, so complex ions are given, the order in which the wavelength of the light will be absorbed. Very conceptual question, this one. So understand, if you have strong field ligands, splitting will be more, right? If splitting will be more, we require higher energy radiations. Higher energy radiations means wavelength will be lesser. So please think in that way and answer. Sham, I won't recommend you to skip amines. PU2 chapters, please don't skip. PU1 chapters, if you are not having time, you can skip, but not PU2. Okay, I am getting answer as B. Please, why everyone is answering B? I am not getting that. Correct order of wavelength. Wavelength of the light. First, see, here I have a, so which is a strong field ligand? Cn is a strong field ligand, right? So in case of Cn, the splitting will be maximum. Okay, this is suppose Cn ligand. Here the splitting will be maximum. Then after that NH3. So here the splitting, this is Cn splitting. I have NH3, smaller splitting than that. Okay. Now here you see NH3 is a strong field ligand, but here there are 6 NH3 and here there are 5 NH3. So definitely the splitting will be minimum in this one, that is NH3, and we have Cn. This is the order in which the splitting will take place. If higher splitting is there, energy will be very high, means if one electron is present here, to go from here to here it will require more energy, right? Energy will be higher, that means what? Wavelength will be least here, right? E is equal to hc by lambda. We know this formula, E equal to hc by lambda. So if energy is higher, then lambda value will be lower, right? It will be weaker. So here the lambda value will be least, and where the energy will be least, here energy is least, that means lambda value will be highest, right? Wavelength here will be maximum, here wavelength will be minimum. So where I can find here? So I can see option number A. Please see here, option number A is having the first ligand. Here the splitting will be less, energy is less, wavelength is highest, okay? Then NH3, then COCN6. I hope all are you getting? Tell me if you all understood this question. Anyone having doubt? I can find still people giving wrong answers. Yes, twist, yes, definitely you will not be getting direct questions, okay? Please understand, you will not be getting direct questions. You have to be very, very alert, attentive, and you have to find the twist in the question. Yes, Purti, I think you got it. Yes, so there are some hearts flowing. Yes, rich kid, you can put your doubt, whatever you have doubt. We will move to the next question. Those students who have understood, please put a thumbs up or a heart symbols are flowing. Solve another question related to this, ma'am. Okay dear, I will try now. I haven't incorporated any question, but next class I will definitely try, okay? But the concept is clear. See, when you have strong field ligands, okay, if you have very strong field ligands, the splitting will be very high, right? Now T2G and EG are very high, gap is there. T2G you have an electron, EG you have one electron, T2G you have one electron, right? For the T2G electron to go to EG, high energy will be required. High energy means, energy will be high means wavelength will be very less. So here wavelength will be minimum. If you have weak field ligands, splitting will be very less splitting, okay? From T2G to EG, if one electron wants to go, it will require low energy. Low energy means more wavelength, okay? I hope this is clear. Okay. Yes. Okay, next we will move to the next question. 23. Which of the following statements about the complex, this complex is given, is wrong? Okay, please try this question. Which is a wrong statement you have to find? So we have to do its hybridization basically to understand this one. So chromium is in +3 state, right? So let me change the color. Chromium is in +3 state, right? What's the oxidation state of chromium? 3d5 and 4s1. If I have this one, so I will have chromium +3, which is 3d3, okay? Now I have here 3d, see, I have 1, 2, 3 and 4. 3d3 I have, okay? And I know NH3 is a strong field ligand, but there is no pairing required because already I have 2 empty orbitals. Then I have 4s and I have 4p, okay? I have 4s here and I have 4p here. So now this D2sp3 orbitals will undergo hybridization to give you 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 6, sorry. So I got 6 D2sp3 hybrid orbitals. So can I say that it is paramagnetic? Yes, I have 3 unpaired electrons, so it is paramagnetic. The complex is an outer orbital complex. You can see I am using 3d orbitals, right? So it is a inner orbital complex. So this statement is definitely wrong. The complex gives white precipitate with silver nitrate solution. You can see if I put silver nitrate, AgCl will form definitely, and that is a white precipitate. The complex involves D2sp3 hybridization and is octahedral in shape. That is also correct statement. So the wrong statement is that which is given, it is an outer orbital complex. So that is why it is wrong. Okay, I hope this is clear. Next, question number 24. Which of the following system is an octahedral complex and has maximum number of unpaired electrons? Very good question. Try this. Anbu, I will request you to please focus on the questions. No personal chats are entertained here. That is your time waste. When questions are given, please do solve that. After that, you can do your chit chat. I don't have any problem, but please don't waste your time, right? We have very few days left. Let's be serious about our preparation. Notes we will be getting in our WhatsApp channel. Please join the WhatsApp channel. All these notes will be uploaded in the WhatsApp channel. Do not worry. It will be uploaded there. You can download it from there. Okay. Yes, no problem, Anvu, no problem. Comet K, very soon we are coming live, dear. For Comet K, we will be launching whatever things we have planned for you. We will be coming either today or tomorrow. Just one day I need. Yes, in PDF form you will get. Others, please answer this question. Harshit has given the correct answer, B. Okay, let's see. I don't know whether it is correct or not. Maximum number of unpaired electrons. Now I have D4 low spin. So I will draw first like this. I have T2G and EG, right? Low spin. Low spin means what? Whenever low spin is there, pairing will take place. Okay, remember. So D4, 1, 2, 3 and 4. So how many unpaired electrons I have? 2. Next D7. Okay, let me draw once again. D7 is there and it is high spin. High spin means no pairing. Okay, so high spin 1, 2, 3, 4, 5, 6 and 7. So I have here 3 unpaired electrons. D9 high spin. Okay, D9. This is option C, option B, option A. D9 high spin. So 1, 2, 3. So no pairing. High spin means no pairing. So 1, 2, 3, 4, 5, then 6, 7, 8 and then 9. I have only one unpaired electron here. Next, D6 low spin. D6 low spin. D6 low spin means 6 electrons. Pairing will take place. So 1, 2, 3, 4, 5 and 6. Okay. So that is 0 unpaired electron. So here we have maximum number of unpaired electrons in option number B. Yes, many of you have already answered. Not visible properly. Why not visible? I think it is clear. I think I am standing there, may not be visible for that. Okay. Yes. No, students, do not think C, E, G, E, J, I. I think C. Please don't think. You can see, draw this and then check. Okay. 24B, those who are getting, is the correct answer. Next question. Crystal field splitting. This is a previous year question. Crystal field splitting energy of COCl6 is given as 18,000 centimeter inverse. The crystal field splitting of COCl4 will be. Yes, this is a very easy question. We have this formula, delta T is equal to 4 by 9 of delta O. Okay. Now, if you see, this is an octahedral complex, this is a tetrahedral complex. So, we have been asked with delta T, where we have been given with delta O, which is 18,000. Right. So, if I do, that is 8,000. Okay. Option number A here. Yes, those who are getting A, absolutely correct. Next, question number 26. When this is when MnO2. Okay, when MnO2 is fused with KOH in the presence of air, the product along with its color is. So if you remember, in the preparation of KMnO4, the first step is MnO2, okay, is fused with air, okay, to get one compound, that is K2MnO4, okay, and then K2MnO4 undergoes electrolysis to give you KMnO4, okay. The question is asked about this one. What is this product and its color? No. KMnO4 is the second step when you do electrolysis. The question is asked only for the first step. When MnO2 is fused with KOH in presence of air, the product formed along with its color. Okay. Are you getting the difference between the two questions? Okay, so it is not as the final product. Final product is KMnO4 and purple, but here it is K2MnO4 and it is green in color. Yes, 26 is A. Okay, next Which of the pair of the compounds is expected to show similar color in aqueous medium? When I will have similar color, I can observe if same number of unpaired electrons are there. Same number of unpaired electrons. So find out the number of unpaired electrons in each of them and tell me where we are getting same number of unpaired electrons. Let us start. Here I have option number A. Okay, Fe2 plus, right? Fe2 plus is 3d6, right? 1, 2, 3, 4, 5, 6. So Fe2 plus is 3d6, and 3d6 if I draw, okay, 1, 2, 3, 4, 5 and 6. Number of unpaired electrons is 4 here. And I have Cu2 plus. Cu2 plus is 3d9, and 3d9 has one unpaired electron, so they don't have same unpaired electron, so they will not have similar color. VoCl2 and CuCl2. Let us see. For vanadium, let it be X, then -2, and here I have -2. So that is +4. So vanadium here is in +4 oxidation state. Scandium, titanium, vanadium. Vanadium is 3d3, 4s2. And here if I have vanadium +4, it will have 3d1, and number of unpaired electron is also 1. Now if you see copper 2 plus, copper 2 plus has also one unpaired electron. We have just checked here. So you can see in option number B, both the compounds have same number of unpaired electrons, so they have similar colors. That is option number B. Okay. Yes, rich kid, I will answer your question please, but let us finish the question first because many students are waiting. Let's do 2 more questions are there. Ammonium dichromate is fused in some fireworks. The colored powder brown, the green colored powder blown in the air is. So what is, when you ammonium dichromate, okay, when it is heated, what is that green color powder that is formed in the reaction? Okay, so you can see the reaction. This is when ammonium dichromate is heated, you will get N2 plus Cr2O3 plus H2O. So the green colored compound here is Cr2O3. Many of you have answered it correct. Very good. Okay, next. Number of moles of K2Cr2O7 required by 1 mole of SN2 plus is. Very good question this one. Yes, EJI, that is correct. Yes. Number of moles of K2Cr2O7 required by 1 mole of SN2 plus. Okay, let me see, let us discuss how can we solve it. So I have this equation, see, Cr2O7, just remember Cr2O7 2 minus will get reduced to Cr3 plus. Okay, now if I want to balance here, this is 2 Cr3 plus, here the oxidation state is +6, here the oxidation state is +3. So +6 to +3 I will have 3 electrons, and for 2 chromium I will have 6 electrons. So what is happening here? The reduction is because of 6 electrons. Okay, now I have 7 water. I am just writing, balancing it quickly. 7 water because 7 oxygen. To balance the hydrogen, I will add 14 H plus. Remember, always to balance oxygen, add water. To balance hydrogen, add H plus. This is the first equation. Now, SN2 plus will get converted to SN4 plus, right? Oxidation by the loss of 2 electrons, right? Number of electrons should be same. So, this equation is to be multiplied with 3. So, what I will get the equation? Cr2O7 2 minus, okay, plus 3SN2 plus. Okay, rest I am not writing, just I need this relation. So what I am saying that for 3 moles of SN2 plus, I require 1 mole of Cr2O7 2 minus. For 3 moles of SN2 plus, 1 moles of dichromate. For 1 mole of SN2 plus, I will require 1/3 mole of Cr2O7 2 minus, right? So for 3 moles, 1 mole is required, so 1 mole, 1/3 will be required. So option number B. SN2 plus, No dear, see, the number of moles of K2Cr2O7 reduced by 1 mole of SN2 plus. SN2 plus is reducing K2Cr2O7. Itself it will get oxidized. Okay, please understand, number of moles of K2Cr2O7 reduced, which is undergoing reduction, K2Cr2O7. By whom? By SN2 plus. I hope this is clear. SN2 plus is undergoing oxidation, right? Okay, I have made a small error. One second. Just a minute. These 2 electrons will come on this side, right? Okay, sorry here. This is 2 electrons. Okay, I hope this is clear now. So 2 electrons is coming on this side. So I can have now 6 electrons. SN2 plus is getting oxidized. 6 electrons will get cancelled. I have multiplied 3 SN2 plus and Cr2O7. Right? I hope this is clear now. Okay, fine. This type of question is also very common with KMnO4 and K2Cr2O7. So this general balancing you should be knowing, basic idea of balancing. Amphoteric, I think everybody should be able to answer. Amphoteric oxides. Okay, just a minute. Okay, students, it is visible now. You can please do. Just a minute. I am having so many things on my hand. Yes, please answer the last question. Yes, which of the oxides are amphoteric in nature? Amphoteric in nature. Very easy question, very easy question. Amphoteric in nature. Bhagesh, I will explain once again, don't worry. Okay? No dear, amphoteric oxides you should know. This is very basic question. Amphoteric oxides are your, yes, let me see who is able to answer. B. B, is it B? A. Okay, take your time and think. Many of you are giving different answers. Please check your time. Yes, those are saying A, that is correct. Okay. V2O5 and Cr2O3 is an amphoteric oxides. Yes, A is correct. Kavita and all those of saying A, that is the correct answer. Okay. Yes. Okay. So that's all, students, in today's class. I hope all of you have enjoyed. Questions I know are little bit on the tougher side, but yes, we have last 15 days. We have to do some different types of question as well. Okay. So why? Because Bhagesh, you have to remember amphoteric oxides, acidic oxides, basic oxides, they are examples you have to remember. Okay. So that is given in your DNF block chapter. There is a section oxides. So please go there and remember the amphoteric oxides examples. They are very important. Okay. So I hope this session was well, but here it doesn't end. I have a homework question for all of you. Okay. So please take a screenshot and you have to solve. Ayush, ma'am, what does amphoteric oxides mean? Okay, Ayush, amphoteric oxides means those oxides which can behave as both acids and bases, means which can react with both acids and bases. Okay, those are amphoteric oxides. Okay. So this is the homework question. I want all of you try this question and put down the answer in the comment section. Okay, all of you should answer this in the comment section. In the next series, whenever I get the class, I will be discussing this question. Okay. Yes, rich kid, ma'am, please reply to my question. Yes, definitely, dear. I am here to reply to your question. So your question was till not prepared. say some tips and techniques to get under 1000 rank. Okay, dear, if you have not prepared anything till now, just focus on PU2. Okay, first do the complete revision of all the chapters. If you see, if you are just dealing with PCM, okay, physics you have 14, chemistry 13, and maths 13, chemistry 10, so you have almost 37 chapters. Okay, so at least try to do 5 chapters per day. Okay, or I can say 4 chapters per day. Okay, so you will be able to complete in 8 to 9 days. You will be able to complete the syllabus. What you have to do, you have to watch the one-shot videos. Our channel has all the chapters one-shot videos. You can watch that, or if you have already prepared short notes, revise that. That's the first thing you can do. Second thing is last 10 years PYQs you have to solve. Chapter wise there is not much questions. Each chapter 25-30 questions are there. So please solve last 10 years of PYQs of PU2. Okay. Third, I will say mock test. Okay, if you have any book you can take, otherwise our Abhyas test series is there, just 1498 rupees. You can take the mock test and prepare questions from there. Okay, if you do these 3 things, then definitely you can get below 1000 rank. Okay. Yes, I hope I have already given answers. Yes, Saminathan, you can watch Masterstroke at this point of time also. EJI pH is equal to 13. Very good, dear. Very good. You have answered the question correctly. Rich kid, high weightage topics. Dear, all the 12th chapters are high weightage. There are 10 chapters. All these chapters are high weightage. Out of amines and biomolecules, you can do any one, but all other 9 chapters will be very, very important. Fine, rich kid, you can do last 5 years of questions. That is also okay. Last 5 years of previous year questions you can solve. Okay. Yes, students, let's write down once again that I will put my 100%. All of you, my dear children, we are just left with few days. Let's not waste our time. Let's not think about anything except KCET examination. Okay, please don't think what will be my rank, what will be my PU board marks, whether I will qualify or not. Only thing, just close your eyes and put your 100% efforts. Okay, what else doesn't matter at this point of time. This time is where you can make or break. If you waste this time, then nothing is going to come to your hand. So you have to use this last days very, very efficiently. Okay, so we are having top 30 question series, we are having rank booster series. So please follow this series every day. You will be getting 30 questions you can practice. And if you have if you are able to, please take our mock test, that is our Abhyas KCET test series. That will definitely help you to boost by 10 to 15 marks or even 20 marks. You can improve by writing so many tests. Okay, so please do that. Okay. EJI, I don't know, I think 5th April, but no confirmation is there about that. Yes, Tabu, by studying second PUC chapters perfectly, you can able to get 40 plus marks easily. Okay. Okay. So students, how was the session? Did you find, I know the questions were little bit on the tougher side, but it was not difficult. If you think properly, if you take time, just revise all these 30 questions once again. Okay, please solve it once again and revise these questions. Everything will be on track. Do not worry. Please do hard work. Please practice. And yes. Okay students, so we can wind up the class. It's already going to be 2 hours and I'm very happy that all of you watched the full session. Nobody left in the between, so I'm very happy because of that. And yes, okay, Aman shows the true spirit. Ma'am, next class give harder questions. Yes, next class we are coming with next 5 chapters. Okay, I'll include some of the chapters from DNF block, because in this session you can see less numbers of DNF block questions were there, and some organic chemistry questions we will include. Okay. Okay, fine students, then let's have a break now. These all PDF will be uploaded in our WhatsApp channel. You have to join our WhatsApp channel. Link is there in the description section. Abhyas test series, if you want to buy, the link is there in the comment section, sorry, description section. Yes, Rakshita, this session and top 30 questions can cover all the concepts, definitely. When is next? So dear, now it is a cycle. So yesterday was physics, today is chemistry, day after means tomorrow will be maths at same 12 p.m. and then we will have biology, and next cycle again physics will start. Okay, so do not worry, and that's all students. Bye bye, take care and have your lunch, and please go to study after taking a proper break. Okay. Okay, Moenil, ma'am, smile please. So yes, definitely I will be smiling, but now I'm also very tensed because we have few days left, exams are there, so I'm also tensed because of you. So okay, those who have JEE, all the very best. Okay, JEE Anbu, all the very best for your JEE exam, dear. Okay, chalo, bye bye students. Please take care of yourself, take care of your health and study. Close your eyes. Just one thing you have to keep in your mind. Study like anything for the next 14 days. Next whatever days left. Okay? Yes. Bye bye. All of you. Chalo.